Hello everyone, welcome to a new video in the channel. We are still doing some performance tests here. So today we have the AMD Ryzen 9 7950X. We are gonna be seeing its performance in some benchmarks and comparing it with the previous 5900X. We don't have a 5950X available to compare, but these 5900X tend to outperform the 5950X in some single core benchmarks, so we are going to be focusing more on that so we can see the single core improvement in this generation. And also we have already done the similar comparison with the new Intel i9 and the previous one, which these two doesn't have the same number of threads either. So this comparison is not as weird as it could sound. And well, with that said, let's go to the benchmarks. Starting with 7-zip, we can see improvement for the 7950X of 37% in the compression side and 52% in decompression. In Cinebench, due to the difference in the core count, we can see a performance increase in the multi-core test of 82%, but if we look at the single core test where we can better see a comparison for the gains of this generation, then the improvement is 28%. Going to Blender, we have improvements from 76% to 85%. In V-Ray on the CPU test, we can see an improvement of 87%, as well as a little improvement on the GPU performance of 1 to almost 4%. Now in Adobe Creative Cloud, using the Puget Bench test, we see a 24% improvement in Photoshop. In Premiere Pro, the improvement is 27%. And finally, in After Effects, the improvement is 35%. Starting with games, we have Civilization 6, where we can see that for the 7950X, the average frame time is reduced by 25%, and for the 1% low by 16%. In addition to that, we have the average turn time reduced by 35%. In Cyberpunk at 4K Ultra Quality with Ray Tracing active and DLSS in the quality option, we have the same average frames per second, but we can see an improvement on the 1% low of 20%. Now deactivating both Ray Tracing and DLSS again at 4K, the average frames per second remain the same, but we can see a small loss in the 1% low for the 7950X of about 3%. Going to 1080p medium quality, we have a 17% gain in the average frames per second and 6% increase in the 1% low. In Metro Exodus at 4K Ultra Quality with Ray Tracing active and DLSS in the quality option, we see a small improvement in average frame rate of 5% and just over 7% in the 1% low. Now disabling both Ray Tracing and DLSS again at 4K, we have a similar scenario with 5 and 8% improvement. And going to 1080p medium quality, we see now gains of 16 and 17%. In Horizon Zero Dawn at 4K Ultimate Quality, we see the same average frames per second, but at the same time we can notice an improvement on the 1% low of 17%. Now going to 1080p original quality, we see a gain of 25% in the average frames per second and 9% in the 1% low. In Shadow of the Tomb Raider at 4K Ultra Quality with Ray Tracing active and DLSS in the quality option, we see an increase in the average frame rate of almost 8% and from 16 to 28% on the CPU side. Again at 4K, but disabling both Ray Tracing and DLSS, the average frames per second change is just about 2%, but we can still see an improvement on the CPU side from 16 to 31%. Now at 1080p medium quality, the improvement in average frames per second is 24%, and on the CPU side from 14 to 31%. In Rainbow Six Siege at 4K Ultra Quality with DLSS in the quality option, we have virtually the same average frames per second and a small gain in the 1% low of around 4%. When disabling DLSS at 4K, we have a similar scenario, but in average frame rate and 1% low. And finally, at 1080p medium quality, we have an improvement in average frames per second of 13% and 29% in the 1% low. Well, as we could see, we have some improvements in gaming at 1080p from 8 to 18%, and also in 4K we are more limited by the GPU. We could see some small improvement of up to 6%, and in the productivity part we could see that obviously the 7950X is faster than the 5900X just because it has more cores and threads. But if we saw some tests like Cinebench with the single core test, we can see that the improvement is also around 28%, so this is a very good generational improvement. And I think that this time the CPUs are not really the problem, but the platform, because with the new motherboards and new socket, and also the fact that you now need to use DDR5 memory, which is also more expensive, I think these details are what are affecting AMD this time, and this is one of the reasons why I think the new Intel CPUs are performing better, because they are also compatible with last gen motherboards and DDR4 memory sometimes. So we need to see what's going to happen, and if you want to update to AMD, we also need to remember that usually Intel gives just 1 or maybe 2 generations support for their motherboards, and if you want to upgrade after that, you need to buy a new motherboard. And AMD usually takes several generations with the same platform, so if you change now to a new motherboard, maybe you could be using it for several generations instead of 1 or 2 with Intel. So we need to see if that's really the case again. And well, I think that's it for now. I hope this video was useful if you are trying to decide between upgrading your CPU, and we'll see you in the next video.